Alright, so let's review how to find any derivative in AASL math. Okay? So prior to watching this video, you should have experience using the power rule, chain rule, product rule, quotient rule, and you should know how to find the derivatives of exponential functions with base e, derivatives of natural log functions, and derivatives of trig functions. Okay? So let's take a look at the first example. So let's say we have y is equal to 5x to the third minus 2x plus 1. If we need to find this derivative, it's going to be super easy. We can just power rule this, 15x squared. All right, power rule this, that'll just be minus 2, and then that's our derivative. Okay? Let's say we have y is equal to 5x to the third over 4. Now, here's where you need to be careful. Just because you see division doesn't mean you have to use the quotient rule. Okay? If you can avoid the quotient rule, you always want to avoid the quotient rule because the quotient rule is a lot more complicated sometimes. So this problem here, we want to rethink this problem, and let's say we rewrite this as 5 over 4 times x to the third. So these two mean the same thing, right? But when you rewrite it like this, you should recognize that, hey, I can use the power rule to find this derivative, which makes finding the derivative a lot easier. So we have y prime is equal to, we're going to get 15 over 4 x squared. Okay, so super easy derivative using just the power rule and avoiding the quotient rule. Okay, let's take a look at another example. So let's say we have something like y is equal to 3 over the square root of 5x plus 1. Now, once again, like I said, if you can avoid the quotient rule, you want to try and avoid it. So just because we see division here doesn't mean we have to use the quotient rule. Because if the top number here is a constant, right? If this is a normal number, it doesn't matter if it's positive or negative. If this is a constant, what we can do is we can bring what's on the bottom here to the top using our exponent rules. So first of all, the bottom here, I can rewrite this, right, as 5x plus 1 to the 1/2 power, right? So if I want to bring all of this to the top, this exponent is just going to become negative. So we're going to get y is equal to 3 times 5x plus 1 to the negative half, right? So I have not taken the derivative. I've just rewritten this in a different way so that now I can take the derivative easier. Because if it's written like this, all we need here is just a chain rule to do this derivative, right? So we get to avoid the quotient rule. So we get y prime is equal to, all right, multiply 3 times negative half, that's negative 3 over 2, times 5x plus 1, negative half minus 1 is negative 3 over 2. And then remember chain rule, right? Now we need to take the derivative of the inside, which is just going to be 5. Okay? So our derivative, if we simplify all this, so negative 3 times 5, that's negative 15 on top. On the bottom, we've got the 2. And then if we move this back to the bottom, because this exponent is negative, this is going to give us 5x plus 1 to the positive 3/2 power. Okay? All right, let's try a couple more. So let's say we have y is equal to 4x over 2x plus 3. Okay? Now this problem here, right, you have to use the quotient rule, right? Now technically, you can actually still move this whole binomial to the top and have a negative exponent, but I only like my students to move the denominators to the top if the top is a constant, right? So this problem here, I would say just do the quotient rule is probably your best bet. So we're just going to quotient rule this. So quotient rule says we take the bottom, right? All right, so we've got the bottom here, 2x plus 3. Derivative of the top, which is 4, minus, put a bracket, we have the top, derivative of the bottom is just 2, right? All over the bottom squared. So that's the quotient rule, the way it works. Derivative here. So the derivative, if we simplify this, so that's going to give us 8x plus 12, right? Now over here, this is going to give us 8x, right? So minus 8x. So these cancel each other out. So this is how we're going to end up with just positive 12 at the top over, right, 2x plus 3 squared. So that would be our derivative. Okay? Let's go ahead and check another one. So let's say we have y is equal to sine 3x times e to the 4x, right? So now this problem here, you have to recognize right away that I'm going to need a product rule. You have to think of this right here, right, as a separate function, right? And then you have to think of this one over here as a separate function. So think of these as two separate functions being multiplied with each other. That's why we need a product rule here, okay? So y prime is equal to, so the derivative of this trig function, remember trig functions, think of them as compositions, so we need chain rule. So the derivative of the outside is just the trig function, sine. So the derivative of sine is cosine. We keep the angle the same. Then times the derivative of the angle, which is 3. And then we keep this one the same, the e to the 4x. Plus, now I keep the first function the same, sine 3x. And then I take the derivative of the second function. That's just going to be e to the 4x, right, and then times 4. And then if we simplify everything, right, so typically anytime you do product rule, there's going to be a GCF that you can take out, right? So I see that, well, what can I take out? I can take out a e to the 4x from here and also an e to the 4x from here, right? And then this is 3, this is 4, there's nothing else. So my GCF is going to be e to the 4x. So if I take out e to the 4x from here, what am I left over with? 3 times cosine 3x, right? Plus, and then I would take out e to the x from here, I'm left over with 4 times sine 3x, right? And then that would be my answer, okay? Let's take a look at another example. So let's say we have y is equal to 3x to the 4th power over, right, 4x plus 1. So this problem here, another example where we need to use the quotient rule. So quotient rule says, okay, I take the bottom times the derivative of the top. Derivative of the top is going to be what? 12x to the 3rd minus, and then I take the top times the derivative of the bottom, which is just going to be 4, all over the denominator squared. So if we simplify this, so if I distribute this 12x to the 3rd here and here, that's going to give me 12 to 4, that's 48, x to the 4th plus 12x to the 3rd. This is minus, and then we have 4 times 3, which is going to be 12. All right, 4 times 3 is 12, x to the 4th. All right, so we can simplify these like terms right here. So it looks like our derivative is going to be 36 x to the 4th plus 12 x to the 3rd all over 4x plus 1 squared. And there's nothing else to simplify, so that would be our answer. Okay? All right, let's take a look at another one. So let's say we have f of x is equal to 5 times e, right, to the 3x squared minus 2x plus 1. Now, this 5 is multiplying with this, but we don't need a product rule here, even though these are multiplying, because 5 is just a constant. Remember, we use product rule when we're multiplying functions, right? Functions are things with variables, okay? So the way we take this derivative, well, the 5, just keep the 5 here, and then what's the derivative of just this? Well, it's the exact same thing, first of all, times the derivative of the exponent, which is going to be 6x minus 2. If you take the derivative of the exponent on top. And then let's just simplify everything. We're going to end up with, well, 5, we could distribute it here and here. We can think of that as 30x minus 10, right? And then times this e to the 3x squared minus 2x plus 1. All right, so let's take a look at the next example. So let's say we have a natural log. Let's say we have natural log 4x to the third plus 5x minus 3. So you have a natural log, right? So remember to take the derivative of a natural log. First, you take the derivative of whatever's inside here. So that's going to give us 12x to the third plus 5, right? Divided by whatever this is right here. So 4x to the third plus 5x minus 3. And then sometimes if there's GCF, you can take out, and you can factor the bottom and stuff, but this one you can't really do anything, so there's no other simplifying we can do. Okay? All right, so let's take a look at some more examples. So let's say we have like y is equal to 7 times sine 4x, right? So remember, this is like the angle for the trig function. So if you're taking this derivative, so remember the 7 is a constant, it's just there. So the derivative of sine is cosine, keep the angle the same, times the derivative of the angle, which is 4. And then we just simplify, clean everything up. We're going to end up with 28 cosine 4x. Okay? Okay, let's take a look at this next example here. So let's say we have y is equal to 3 times cosine squared 5x. Well, first of all, you have to understand that this right here, this means the same thing as cosine 5x being squared, right? So then we have y is equal to 3, right, times cosine 5x, right, being squared. Now, you have to recognize right here, I just need to use a chain rule, right? We're going to chain rule this. So when you chain rule this, you'll get y is equal to 3 times 2 is 6 times cosine 5x. So we keep this the same. Minus 1, I get 1. Now we need to multiply by the derivative of the inside. Derivative of the inside, so what's the derivative of cosine? All right, that's negative sine. Keep the angle the same. And then times derivative of the angle, which is 5. Then we need to clean all this up. So first of all, I have a negative here. Everything else is positive. So we're going to end up with negative 6 times 5. That's 30. Cosine 5x, all right, times sine 5x. Now they may be a little bit tricky in trying to manipulate this using double angle or something like that. So that's just something to think about if it's a show problem, right, on like an IB test or something. All right, so let's take a look at the next example. So let's say we have y is equal to natural log square root 3x plus 1 over 5x minus 3 to the 4th power. So first of all, you should recognize that I don't need to do the quotient rule for this problem because I can rewrite this using the natural log properties so that it is no longer a division here, okay? So if I rewrite this using the natural log properties, this would be, well, first of all, I'll change this, right, to 3x plus 1, change the exponent form. So now when I use the natural log properties, this exponent can go to the front, so I get 1/2 natural log 3x plus 1, and then since this is in the denominator, I'll have a minus, and then 4 natural log 5x minus 3. So now that I've rewritten this problem like this, I can avoid doing the quotient rule when I'm trying to find the derivative, which makes it a lot easier, okay? So then we're going to get y prime, the derivative is equal to, so we have this 1/2 here, so kind of just have the 1/2 times. Now if you're taking the derivative of a natural log, remember how that works is you take the derivative of what's inside here. In this case, it's just going to be 3 divided by whatever this is, 3x plus 1, minus 4 times, all right, we've got this natural log 5x minus 3, so we take the derivative of what's inside here, which is just going to be 5, divided by whatever this is, 5x minus 3. And then if we want to find the final answer, kind of multiply, clean everything up, so it looks like we're going to end up with 3 over, you can distribute the 2 into this if you want, that's really up to you. So we would get, let's say, 6x plus 2 minus 20 over, all right, 5x minus 3. Okay, so sometimes you can leave it like this. If it's a show problem, it might have you get the common denominator. So it just all depends on the question, right?